Apart from that, remember that for a block and tackle system, when the effort is applied in the downward direction, like so, in this system the effort is applied in the downward direction. So whenever the effort is applied in the downward direction, the mechanical advantage and the velocity ratio is always equal to the total number of pulleys. Pretty important. So what do you exactly mean by this? If you count the total number of portions of the string, that means 1, 2, 3, 4, 5 and 6. Notice that for the 6th portion of the string over here, the tension T which acts upwards is being countered, or it is being nullified by the effort E which acts vertically downwards. This tension T in the last segment of the string does not help in lifting up the load L in the upward direction. Why? Because it is being nullified by the effort E. So as a result of which the load L is being supported by the remaining 5 portions of the string. That means load L is being supported by the different 5 portions or the segments of the string. So we can say load L is equal to 5T and not 6T. From the last portion of the string, we know the effort is equal to T. The effort nullifies the tension, and we know the formula, mechanical advantage equals load upon effort, which is nothing but 5T upon T. T cancels out, that leaves us with mechanical advantage is equal to 5. Remember this always. Now this 5 is nothing but the total number of pulleys, 1, 2, 3, 4 and 5. This explanation you are not gonna easily find anywhere, right? So please pay careful attention that when the effort is applied in the downward direction, the mechanical advantage and thus the velocity ratio is equal to the total number of pulleys, whereas if the effort is applied in the upward direction like so, the mechanical advantage and the velocity ratio is always 1 more than the total number of pulleys used. Like in this case, the load L is being supported by all the segments of the string. Remember, the effort E and the tension T in this segment both act in the same upward direction. So the tension T is not getting nullified by the effort E. So we can say the load L is equal to 1, 2, 3, 4 and 5. Again, there are 5 different or all the portions of the string, right? The effort is equal to T again, and as a result mechanical advantage is equal to load upon effort, which is nothing but 5T upon T, which is again 5. Now notice this 5 is 1 more than total number of pulleys. The total number of pulleys is 1, 2, 3 and 4. So always remember, when the effort is applied in the upward direction, the mechanical advantage and the velocity ratio is always 1 more than the total number of pulleys used. So these are the 2 important points that you should always remember. Always take the direction of the final effort into count. If the final effort is in the downward direction, MA is equal to total number of pulleys, and if the final effort is in the upward direction, MA is 1 more than the total number of pulleys used. Always remember this. Now we have a question from ICSE 2015 for worth 4 marks. It says a block and tackle system has a velocity ratio 5. That means the total number of pulleys is 5. What does this imply? It implies that we can quickly draw a block and tackle system with the number of pulleys in the upper block as 3, while the number of pulleys in the lower block would be 2, right? So 5 can be written as 3 plus 2, as the number of pulleys in the upper block is 1 more than the number of pulleys in the lower block. So this is how a diagram would look like. We have 1, 2 and 3 pulleys in the upper block and 1 and 2 pulleys in the lower block. Now we've seen that whenever the number of pulleys in the upper block is more than the number of pulleys in the lower block, we start with the hook of the lower blocks. So the string would start from the hook of the lower block and it would wrap itself around each of the pulleys so as to have the final effort E being applied in the downward direction. So this is how a final diagram would look like. Draw a neat label diagram of system indicating the direction of the load and the effort, right? The load obviously will act in the downward direction. The effort E we know acts in the downward direction. And even though if it is not asked, it is always a good practice to mark the tension in each segment of the string T acting in the vertically upward direction. Now we are given that if Rohan exerts a pull of 150 kg, what is the maximum load he can raise with this pulley if the efficiency of this pulley system is 75%. Now Rohan exerts a pull of 150 kgs, right? So the effort E applied by Rohan in the downward direction would be 150 kgs, and we are asked what would be the maximum value of the load L that he can pull if the efficiency of the system eta is given to be 75%. Club the given data. Effort applied is 150 kg, efficiency of the system is 75% or 0.75. We know that efficiency is equal to MA upon VR times 100, right, as a percentage. So efficiency as a percentage is 75%. So 75 is equal to mechanical advantage upon the velocity ratio. From the question we know velocity ratio is 5, right? So efficiency is equal to MA upon 5 into 100. We can quickly calculate MA. MA is equal to 75 times 5 upon 100, which is nothing but 3.75, right? Also we know mechanical advantage is equal to load upon effort. So 3.75 would simply equal to the load L is to be calculated upon effort applied is 150 kgf, right? So the load L becomes 3.75 multiplied by the effort, that is 150 kgf, which is nothing but 562.5 kgf. So you see, this is an advantage of having a combination of pulleys. By simply applying an effort of 150 kgf, a boy can lift up a load as high as 562.5 kgf. So this is a very big advantage of using a block and tackle system of pulleys. So this question was asked in ICSE 2015 for worth 4 marks. So it is very easy and very scoring. Just remember how you need to break up the velocity ratio into the number of pulleys in the upper and the lower block each.